Today we're going to cover log transformation. And the goal of log transformation is to take skewed data and make it look closer to the normal distribution, which is one of the assumptions we have when we're modeling data in, say, a linear regression, for example. So let's take an example. Let us look at the distribution of, say, number of weekly listens. Music listens. And over here, let's say number of songs with the corresponding number of listens. So we have lots of songs with, I don't know, say 0 listens. Some with 1, some with 2. Maybe there's 10, 100, thousands. Let's say it goes all the way to 1 million. So, as I mentioned before, most songs really don't have that many listeners. Maybe 0, 1, these are like struggling artists, struggling musicians, mediocre songs that don't have that many listens. And then what the data looks like, it's going to be quite skewed. And it's going to be quite right skewed. So by the time you get to, say, 1 million, you're going to have some folks with 1 million listens, but really not many. You might have, I don't know, Taylor Swift, got Beyonce, I don't know, a couple K-pop folks, for example, with 1 million plus. And the issue with this is your data is actually very skewed. It does not look like a normal distribution at all. It might actually look something like this, actually, if I made this a bit smoother, where lots of folks have 0 or a few listens, and a handful of folks are only getting 1 million plus listens. So, what does log transformation look like? Let's now do our log transformation. Our y-axis, again, is going to be number of songs. And then here on our x-axis, we're actually going to take the logarithm of weekly listens. It's most cases, it's actually going to be weekly listens plus 1 because log of 0 is undefined. So just adding that 1 there makes it, let's see, log of 1 is like 0. So by taking the log of your x-axis, what does the data look like now? So you're going to have 0, you're going to have 1, 2, 3, 4, 5, 6. Most interesting part is log of 1 million actually equals 6. So the distribution here is going to look something like this, actually. It's not going to be as skewed as the raw data. They're actually going to squish a lot of the data to make it a little bit closer to normal. Definitely wouldn't call it normal. It's veering a bit closer to what normal might look like. So that's an example of looking at number of listens. Other examples of like skewed data that could benefit from logarithm transform. You can look at, say, revenue. Again, lots of folks are lower middle income, and then a couple folks are millionaire billionaires. Well, I mentioned revenue, so that's like company revenue. A couple small companies, and a couple giant tech giants. And income was my first example. You could look at number like video views. You could look at like likes, for example. Again, Beyonce might post something, get 1 million likes. I might post something, get, I don't know, 2 likes. And most people are like me, just get a few likes on their content. And that's log transformation.